This is a joint work with Shahar Dobzinski. And just a small disclaimer before starting. So my background is computer science. So I'm a computer scientist. So maybe this kind of talk will be in a little different style than what you used to. But again, feel free to interact and ask questions if there's anything that is unclear. Okay. So our starting point is truthful mechanisms. And many of the works in algorithmic mechanism design, at least, look for truthful mechanisms, or other literature is known as domain strategy mechanisms. And the idea is that we need to incentivize the participants, the bidders, to report their true variations. And if we are not going to do so, then they're going to lie regarding their variation. If by lying, they can increase their profit. So, for example, get an item for a lower price. And what we ask in this work is it really the case? So, um, sorry. And research from behavioral economics suggests that this is not necessarily the situation. In a very cool experiment, Fischerbecher and Forney asked participants to roll a six-sided die in a cup and report the results. And the payoff was determined by the number that they rolled. So the higher the number, the higher the payoff. Now, this is a really nice setup because on the individual level, we cannot tell whether a certain individual lied or not. But on the aggregate, since we do know which kind of distribution to expect, we can tell how much people lied. And this experiment was replicated many, many times in different populations, different variations. And in 2019, Abel et al. Took 90 papers of this kind and ran a giant meta-analysis. The high-level finding was that participants only collect about 25% of the potential gain. So to collect all the gains, people should always just report six, always lie. Together with this meta-analysis, they also put up a website that has all of the data from all of these experiments, and you can filter it relative to different parameters. So what you see in this graph is data just from experiments that were run in Israel. On the x-axis, this is the number that was reported, so 1, 2, 3, 4, 5, 6. And on the y-axis is the percentage of people reporting it. Different colors correspond to different experiments. And what we can see here is first that 1 and 2 are underreported, so they are below this dashed line of 1/6. And 5 is more overreported than 6. So people do not lie to the full extent. And there were many models that were suggested to explain this preference for truth telling. And another thing that this meta-analysis did was to use the data that previously collected and also they ran some new experiments in order to falsify many of these models. And the models that survived this elimination combine two things. So one, a preference for being seen as honest, and another, a preference for actually acting in an honest way. Another paper, which is actually going to be more relevant to the setting we consider, is by Gnisi in '05. And here a very simple example. This is kind of a sender-receiver game. So we have two participants. The sender has all of the information, and the information is that there are two alternatives. And for each alternative, the sender knows how much the sender gets and how much the receiver gets. Okay, so we have option A, sender gets 5, receiver gets 6. Option B, sender gets 6, receiver gets 5. And then the sender sends a message to the receiver. It could be one of two messages predefined. So either option B will earn you more money than option A, or the reverse message. So option A will earn you more money than option B. The receiver can do whatever he wants, listen to the message, ignore it, whatever. He makes a choice. And then according to the receiver choice, the payoffs are determined. However, it is indeed the case that senders believe that receivers are going to follow the recommendation, and receivers are in most cases, follow the recommendation. So it's not just some like random cheap stuff. And now the question is, how do the message the sender sends is going to be different in different treatments. So when the payoff to the sender and the receiver is different. And in all of those treatments, the option that gives more money to the receiver is option A. So if the sender is recommending the receiver to choose option B, then the sender is blind. Okay, so they did three treatments. First one is the one that we've just seen. So this is a symmetric one, and both the sender and the receiver don't have a lot to gain or lose from the preferred option. Second one, in option A, the receiver gets much more than in option B, so he has much more to gain. And in the last option, both senders and receiver have a lot to gain in the preferred respective options. Okay, so let's see how the percentage of lying again is recommending on option B differs on these treatments. So in the first treatment, a little bit more than a third of the senders lie. In the second one, this drops down to 17%. So now that the receiver has a lot to lose from this bad recommendation, there are significantly less senders that are recommending it. And in the last one, a little bit more than half lied. So now the sender also has a lot to gain from this lie. And what we can conclude from this is that when the benefit from lying is smaller than the receiver's loss, senders tend to lie less. So based on these experiments and others, we came up with two behavioral assumptions. The first one is that individuals have a preference for truth-telling. This is what we've seen in the first set of experiments. And the second one is that when individuals decide whether to lie or not, they also take into account the externalities of their actions. So they also think about what damages they are going to cause others when they choose to lie. And what we do in this paper is refer to people obey these two assumptions as moral beaters. So this is a bit of a mouthful, but all I mean is just people that obey these two assumptions. And we are going to design mechanisms in which people that obey these two assumptions are going to report their evaluation truthfully. So this is the rationale. An alpha moral mechanism, in this mechanism, a player is only going to lie if his profit from lying is larger than alpha times the sum of losses of the other players. And alpha here is between 0 and 1. So let me go over the formal definition. So the setting that we are going to focus on is a very simple setting. So there's just a single item. We are looking for deterministic mechanisms that are individually rational, and there are no positive transfers. So the mechanism cannot pay the bidders. And here's the definition. So a mechanism is usual. There's a pair of functions, an allocation function f, and a payment function p. And we say this mechanism is alpha moral if in every instance, v1 through vn, for every player I and value vi, such that player I can increase its profit by reporting v prime I. So we assume here quasi-linear utilities. So utility is just value minus payment. And what I mean by this notation is this. You can see my cursor, right? Can see my good. So this is the payoff of a player that his value is vi, but he is reporting v prime I, and the rest of the players are reporting v minus I. So this is again value minus pay. So if there is a player that can report something else than vi, and by doing so increase his profit, what we require is that the profit from lying is at most alpha times the sum of losses of the other players from this lie. So a couple of things to note about these mechanisms. So first, this is a true generalization of domain/G mechanisms. So if instead of if we pick alpha equals 0, this is just a domain/G mechanism, right? So every player has this strategy or reporting truthfully that maximizes his payoff. Another thing to note is that the preference for truth telling appears here, in which the players look at truth telling as this kind of default option. So first there is this default of telling the truth, and then they think whether they want to deviate by telling a lie. And when they look at their own gain and the other losses, everything with respect um to this default option of telling the truth. Another thing I want to note here is that this is different than assuming that the bidders are altruistic. So it's not if we assume that the bidders actually care about the utilities of others. It's only under the specific circumstances when they think about whether they want to lie or not that they also take into account the externalities of their actions and what it's going to do to other people. The last thing I want to mention is that this is kind of mechanisms that perhaps more applicable into settings in which the bidders actually know each other. So to take a simple example, think about a department chair that wants to allocate some expensive piece of equipment, and he's doing kind of a small auction for this, and asks each one what's its value for this equipment. So if I know that my friend next door has a greater value for this piece of equipment, it's much less likely that I'm going to exaggerate my value in order to take this piece of equipment instead of giving it to him. Any questions so far? Okay. So let me show you a few examples. Uh, First, I want to demonstrate how moral mechanisms work using two examples. First example, we're going to see that with these kind of moral mechanisms, we can implement the same allocation functions that we can implement using dominant strategy mechanisms, but with different payment functions. So what we can do here is allocate the player with the highest value, but now only charge half of the second price. Okay, this is of course not a dominant strategy mechanism, but it is one moral mechanism, and let's see what. So in this proof, VK is the player with the highest value, VJ is the second highest, and to see that the mechanism is one moral, so first we observe that the player K cannot increase its profit for misreporting. This is just the usual argument for truthful mechanism, right? He's already winning, and if he bids a higher value, then his payment remains the same. If he bids a lower value, then he can just lose. Right? So player K cannot increase its profit. The more interesting case is some player I that in this mechanism, so when we price according to half the second price, player I can actually report another value. So he can report VK plus epsilon and have a positive profit, right? But if player I is one moral, then he's not going to do it if this condition holds. So if his gain from misreporting, which is going to be his value minus the price he's going to pay, so he's going to pay VK over 2. If his gain from misreporting is at most the loss of player K from this, right? So player K previous profit was VK minus VJ over 2. And this inequality indeed holds since VK is greater than VI and VJ is less than VK. So indeed, this inequality holds. So if player I is one moral, so when he decides whether to report his true value or not, he takes into account externalities of the action. So in this case, he's not going to lie. Any questions? Okay. So let's see another example. And in this example, what we are going to see is that with these moral mechanisms, we can also implement allocation functions that are not implementable by strategy proof mechanisms, by domain strategy mechanisms. So for domain strategy mechanisms, we know that the allocation function has to be monotone. So if a player gets the item for bidding VI, he's also going to get the item for bidding anything higher than VI.
Looking at
And for one, yeah. Sorry, can you repeat the question?
I guess it was just accidentally.
Yeah. Okay. Um, so what we see in this example, that using these model mechanisms, we can also implement allocation functions that are not monotone. And this is, we see the allocation function in this picture. So in the gray area, we are not going to allocate the item at all. In the blue area, the item is allocated to player one, and here's the payment. So player one is going to pay one. And in the red line, so when V1 equals 11 over 10, then we're going to allocate the item to player two, and player two is going to pay zero. So this is a non-monotone allocation function, right? So if V1 has a value of 1 and V2 is, say, 2 over 1, then V1 gets the item. And if V1 increases his value to 11 over 10, then suddenly he doesn't get the item. So this is a non-monotone allocation function. And let's check and see that it's indeed a one-mole mechanism. Okay, so this is just a reminder of the definition of what we need to check. And again, if we are in the region in which player one is allocated or the item is not allocated, then it's pretty easy to say that player one should beat its true value, just like in a regular truthful mechanism. The more interesting case is when player two is allocated. And if we are in this region, so V2 is less than 1 over 10, then again, it's fine to allocate player two because player one cannot report anything to get the item. What's more interesting is here. So V2 is greater than 1 over 10. And now what we need to check is whether, again, the gain of player one for the loss is less than or greater than the loss of player two. And the gain from lying here for player one is going to be 1 over 10, since his true value is 11 over 10. And if we would report a different value, he has a payment of 1, versus the loss of player two, which is V2 minus 0. And since V2 here is greater than 1 over 10, then this inequality holds. And again, if player one is 1 mole, then he is going to report its true value, even when it's 11 over 10, and player two would get the item. Okay. So far, we observed that moral mechanisms extend a set of implementable allocation and payment functions. So we can implement with them new allocation and new payment function. And our main question is whether an auctioneer that doesn't care about all this morality nonsense can actually take use of the bidders. So can he actually leverage the morality of the bidders just to increase its revenue? And the answer is it depends. So before elaborating more on the answer, let me tell you a bit more about the properties of these alpha moral mechanisms. This is also a good time for questions, if there are any.
Well, maybe I could ask a question. Could you go back to the first example? Because I think you said so you are assuming that the winner pays half of the second prize, but you wrote it not half of the bid, but half of his value. Actually, I think in this setup, there are dominant strategies. One should bid twice his value. So, if I'm not mistaken.
Yeah, no. To be completely formal, you should write the bids and not the value, but it's proving that if there are one more, they're going to bid the value, so I skip this. You are right that, like, the completely formal definition would use the bids, but this is, actually like doing the next step of proving that they're
But
going to use the values.
In that case, just anticipating maybe what you will tell next. So if there are, I mean, I guess there are many equilibria, so you are choosing, I guess, the best for the seller, yeah. So that's what you are, or sorry, yeah, I'm not sure. So I guess seller, yeah, you want to maximize the revenues. I mean, for example, if you are saying there is a dominant strategy, but somehow you are not interested in that because you're saying there is something better for the seller.
So I'm looking at this at the following way. So one of our assumption was that we have a preference for truth telling, and we are looking at this as we have this kind of default option of just reporting your value. This is the default. This is kind of equilibrium that we are thinking about. And now you're only going to deviate from this if your profit from the deviation, you compare it against the losses of the others. So it's not exactly a definition of equilibrium, but in some sense, because of the definition of default option, what we are thinking about is mechanisms in which this is going to happen. So if all the bidders report truthfully and they are all one moral, then they are not going to deviate. And this is how we construct these mechanisms. And this is also why I'm using kind of the true values instead of the bits. Because we're
Okay.
kind of looking at like this is the default option and now we're checking just deviations.
Okay, thanks. Understood.
Okay, so it's really centered around like um reporting the true value. And it is also tied a bit to um kind of saying that this is maybe more applicable into implementations in which we actually ask the bidders report your true value, right? So in this kind of maybe like a still bid auction in which we ask them to write true value, something like this, in which there's the question of like reporting your value or lying about it. Yeah. Any other questions? Okay. Okay. Um, so let me tell you a bit more about like properties of these mechanisms. And this is kind of a first step towards seeing whether an auctioneer can do something or not. So one of the things I've shown you is that we can take allocation functions that are also implemented by domain strategy mechanisms and use different payment functions to implement them. But unfortunately, this is not going to help an auctioneer that wants to get more money because what we show is that when we have two mechanisms, one is truthful and the other is alpha moral, and both are implementing the same allocation function, then the alpha moral mechanism cannot charge more than the truthful mechanism. So this is not going to help an auctioneer that wants to make more money. Let's see the idea. So first observation is that an alpha mole mechanism is payment independent. So this means that the price of the winning player does not depend on his value. It's usual property, also truthful mechanisms have it, domain strategy mechanisms. And to see that the proposition holds, let's assume towards contradiction that there is a mechanism that charges the alpha mole mechanism charges player I when he wins greater payment than the truthful mechanism. Okay, so this is the picture we have. This is the payment that truthful mechanism charges. This is the payment that the alpha mole mechanism charges. And since this is a allocation function that is implementable by a truthful mechanism, we know it's monotone. So this means this is the critical value, and player I is going to get the item whenever his value is above this critical price, right? In particular, this means you get the item when his value is someplace here, some value here. And in this case, if this is the payment in the alpha moral mechanism, then he's going to have a negative utility, which is a contradiction to a requirement that the mechanism will be individually rational, right? So we established that an alpha moral mechanism implementing the same function as a truthful mechanism cannot collect more revenue. Uh, good. So the next thing I want to show you is going to lead us to kind of characterization of alpha moral mechanism, which will be a little bit easier to work with. So for this characterization, we need the following definition. So we define the potential payment in a payment independent mechanism. This is what player I pays if he wins. So given by v minus I, player I never if sorry, given v minus I, player I never wins, then this potential payment is going to be infinity. So in a sense, this is very similar to the taxation principle of like if you have more items, showing a menu and having a price for each bundle. Um, so let me show an example. So if the value of V2 is greater than 1 over 10, then the potential payment of player 1 is 1, right? Because if he will say his value is 1, then he's going to get the item and pay 1. But if V2 is less than 1 over 10, then this potential payment is infinity because player 1 cannot report any value in order to get the item. Using this potential payment, we define potential profit, which is the difference between VI and the potential payment. And kind of analogous definition to alpha moral mechanism is the following. So we call this alpha profit maximizer. And this is a mechanism which is, again, individually rational. There are no positive transfers. It's payment independent. And the idea here is that this mechanism is essentially characterized by the payment function. So we have these potential payments. You can think about it kind of like as a price that each player presents to the other one. And if there is a player with a positive potential profit, the item is allocated. And if the item is allocated to player J, then we require that every player I, which is different than J, then his profit from potential profit from getting the item would be at most alpha times the potential profit of player J. So we are going to allocate the item to the player that has the maximum potential profit, and we require this to hold for all the other players. Right? Again, so if you take alpha equals 0, then this is a truthful mechanism. So in a truthful mechanism, the potential there could be at most a single player with a non-negative potential profit, and which we can allocate and which we do allocate the item to. Any questions about this definition? Okay. So this is just showing that the mechanism we've seen in the previous slide is also alpha profit maximizer. So in the gray area, the potential profit of both players is negative. In the blue area, the potential profit of player 2 is negative, so we allocate to player 1. And in the red area, when V2 is less than 1 over 10, the potential profit of player 1 is negative, so we allocate to player 2. And finally, when V2 is greater than 1 over 10, then here the potential profit of both players is non-negative. And we allocate to player 2, who has a larger potential profit. Okay. And not going to go into the proof, basically going over the definitions, but an individual rational no positive transfers mechanisms, which is alpha moral, is alpha profit maximizer. So this is another way of looking at those mechanisms, slightly more technical, but easier to work with. Okay. So let's go back to our main results. We're asking whether an auctioneer can extract more revenue from moral bidders. And the first part of the answer is that if the player's valuations are drawn IID from what we call a standard distribution, and we'll give some examples in the next slide, then for any alpha moral mechanism, there exists a truthful mechanism that extracts at least as much revenue. So essentially, if the player's valuations are drawn IID, then the auctioneer cannot leverage their morality in order to collect more revenue. However, there exists a two-player coordinate distribution for which an alpha moral mechanism can extract a higher revenue than any truthful mechanism. And let me give you a few more details about this. So for independent distributions, this is again our theorem. On a technical point, we're working with distributions that are discrete. and the support is epsilon to epsilon, like an epsilon net. Standard distributions include uniform distributions, exponential distributions, and also distributions that have this property. So for every Vj greater than Vi, then Fi, the PDF f small f Vj is at least Fvi over 1 plus Fvi. Now, one natural approach for proving such a theorem would be to build on Myerson characterization of optimal auctions. So Myerson characterizes the payment functions in terms of the allocation function, and then given the characterization, we can completely ignore the payment functions and continue to find the allocation function that maximizes the revenue. This approach inherently fails for moral mechanisms, since we observe that the allocation function is for one moral mechanism is always unconstrained. So we need to develop all machinery required for proving this theorem from scratch. This makes the proof quite complex. But on the upside, our proof techniques also provide an alternative proof to Myerson characterization of optimal auctions when the values are drawn from independent regular distribution. And this is kind of a proof that builds actually more on the prices, in a sense, gradually fleshes out the structure of your prices to get to the optimal auction. And I'm going to, if I have enough time, I'll give you a glimpse on how this proof works. Any questions so far? Okay. So for correlative distribution, we show that there exists a two-player correlative distribution for which an alpha model mechanism can extract a higher revenue than any truthful mechanism. This is the proof idea. Here we write it for alpha equals 1. So we use a correlative distribution that was constructed by Dobzinski and Ideali in the EC18 paper. This distribution works as following. So we have two players. The value of player 2 is between 1 and 1 plus epsilon. And what's special about it is that the lower bits of V2 determines the distribution of V1 in which all the values are greater than 1. So if you know the low bits of V2, you can offer a take it or leave it payment to V1. So an ideal mechanism would be something like this. We first ask player 2 for its lower bits, then we give player 1 a take it or leave it offer based on this distribution. And if player 1 refuses or the price is too high, we're going to sell player 2 for a price of 1. This is, of course, something we cannot implement in a dominant strategy mechanism, right? Because player 2 is not going to just give us its low bits for free. But it is something we can do with an alpha moral mechanism. It's easier to think about it as a one profit maximizer. So what we can do, we set the price that P2 present to player 1, P2 V2 would be just this take it or leave it offer based on this on the distribution. So V2 knows his value, we can set this price. And player 1 set its price to just 1. Okay, and now in one profit maximizer, we're going to allocate the item to the player that has the largest profit. Right? And in this case, if the players are one model, they're not going to deviate, and this is going to be a one profit maximizer. And in this profit maximizer, we're going to always allocate the item, so we're going to collect a significantly high revenue than the best truthful mechanism. Okay. So we know that there exists two correlated distribution for which the auctioneer can make more money, but how much more money can the auctioneer make? And what we show is that the revenue of an alpha moral mechanism is at most twice the revenue of the optimal truthful mechanism. And the way we show it is by showing that by using the fact that there exists another truthful auction. This is called the look-ahead auction. So what the look-ahead auction is doing, the look-ahead auction only sells the item to the player with the highest value, and it's making it a take it or leave it offer based on the values of the rest of the players. And this auction is able to provide a true approximation to the best alpha moral mechanism. So this means it guarantees at most half of the revenue that the best, the optimal truthful mechanism can guarantee. So, the existence of this mechanism tells us that the benefit from kind of leveraging the morality cannot be more than twice. Any questions so far? Okay. So let me just kind of briefly show you how we can alternatively prove milestone characterization, just to give you kind of a glimpse to the techniques that we use. So the setting I'm going to work with is the simple setting, two players, values to own IID from the same regular distribution. And the revenue maximized auction is just a second price with reserve price equals to the monopoly price. Okay, we will denote this monopoly price by X. And as we said, a truthful mechanism is a zero profit maximizer. So if we look at it in terms of the payment, this means that what we need to show is that the mechanism looks like this. So each player, if it has a value greater than X, the monopoly price, then it's going to present the other player his own value. Okay, this would create a situation so that when the players, both of their values are above X, then we have a second price. Right? The player with the highest profit or highest profit is positive is going to have one with positive profit, is going to get the item. And if VI is less than X, then we should set PI VI to be X with the monopoly price. Okay, alternative way of looking at this. And the main challenge in the proof is showing that for VI, which is greater than the monopoly price, then PI VI is greater than VI. So this is what I'm going to give you again a glimpse on how we show it. Okay, so we want to show that there exists a revenue maximizing truthful mechanism in which for every player I, the two players, if the value of a player is greater than the monopoly price, then he's going to present to the other player a price that is at least his value. And here's the proof sketch. So we are going to kind of prove, assuming contradiction that it's not the case, we are going to take an optimal mechanism in which the maximal value V1, such that P1 V1, we call it V2, the price that V1 presents to V2. This is less than V1, and this is maximal. Okay, so there's no other mechanism in which P1 V1 is greater. And we show that there's another mechanism that collects the same revenue or higher, but with a slightly higher price, when P1 V1 equals V2 plus epsilon. Yeah, and by doing so, we can gradually increase the prices exactly until they reach the point of PIVI. So we're not going to get to exactly because of the epsilon net. So it's sometimes going to be like PIVI VI plus epsilon, not exactly VI, but that's just because of the discretization. And what we show is that one of the following cases holds. So either it is the case that we can just increase by epsilon the price that player one presents to player two and get a mechanism that has the same revenue or higher. Or if this is not the case, then it has to be the case that when player two has a value of V2, the price he presents to player one is V1 plus epsilon. And in this case, a mechanism that's doing two things. So one increases the price P1 V1 by epsilon, and two decreases P2 V2 by epsilon. So this mechanism has the same revenue or higher than the original one. And this specific point is where we require that F is going to be a regular distribution. Any question? Okay. So I want to just briefly show you a couple of pictures demonstrating it. I'm not going to get into the details. So this is the first picture. Player one has a value of V1, and this is this kind of picture. The price he's presenting to player two. So means that if V1 player one has value V1, player two has V2, then player two and uh, any value above V2, then player two can buy the item for this price. And the first thing we noticed is that when player one has values greater than V1, then he has to present player two prices that are greater than V2. And this is just by our choice of V1 as the maximal, such that we have a deviation that the price is too low. And also values here greater than V2 have to present player one values that are greater than V1. This is simply because if this is not the case, we're going to have a contradiction to feasibility. Okay, and this is something that happens when we are thinking about strategy proof mechanisms. But in our proof, when we want to prove it actually for alpha moral mechanisms, then this is a situation we need to handle because it is possible for both players to be profitable. Okay. Then what we show is that if the player okay, yes, so V1 is presented. What happens when V1 increases the profit by payment by epsilon? Uh, the change in all of the values here and here is just going to be either positive or going to be the same. The interesting part is when exactly in the instance V1, V2. And in this instance, if this price is less than V1, then we're fine. The revenue can only increase. The problem is if the V2 is presenting player one a price that is higher than V1. And what we do next is show that in this case, the price that V2 presents to player one has to be V1 plus epsilon, what we do here. And again, not going to go into this, but this is the last step. This is the only step we need that the distribution is regular. So now we know again. So V1 present a price of V2, V2 present a price of V1 plus epsilon, and then we check what happens if we simultaneously increase the price of V1, decrease V2, and this is going to be all of the changes in the revenue. And if this is a corresponding definition for regular distributions for discrete distributions, so if this holds, then we can profit from increasing the price that V1, sorry, present to V2. Okay, so this was just to give you, I guess, some idea of how the proof works. And let me summarize. So our work joins a growing literature in cognitive game theory, incorporating behavioral assumptions to well-studied settings. We talked about developing and analyzing mechanisms for moral betas, for standard distribution. We showed that if the values are drawn IID, then moral mechanisms cannot extract more revenue. For quality distribution, sometimes moral mechanisms can extract high revenue. We talked about an alternative proof for Meyerson's characterization. There are many open questions raised from this work. First question, closing the gap. So we've our proof for alpha moral mechanisms work for standard distributions, which is a subset of regular distributions. We suspect that actually holds for any regular distribution. There's the question of whether we can apply our techniques to get a characterization of truthful mechanisms beyond regular distributions to actually get something stronger. And I think question that I find most interesting is whether we can apply these kind of moral mechanisms to more general settings. So, for example, combinatorial auctions in which we have many items and each bidder has a value for each subset of the items. In kind of those settings that are well known, harness of computation results for truthful mechanisms. So maybe moral mechanisms could be a potential way of elevating some of these results. So that's all. Yeah, thank you. questions?
I have one question. I'm sorry I joined late, so maybe you covered this, but um, one thing to think about is, it seems in the extreme, one could extract full revenues if it was infinitely costly to lie. So that's actually a practical situation. So, for example, let's say I'm selling you my car. Uh, I can certainly lie about how much I uh, dislike the color of my car because that's unverifiable. But if I lie about the brakes not working, and you discover that, oh, yeah, these brakes don't work, I just had this big accident, then I'm actually liable for it because it's against the law to lie about the brakes not working, because that's something that's verifiable.
Yeah,
So, do you want to comment on that at all?
I guess kind of the domain we focus on is exactly domain in which the lies are not verifiable, but it's more about just, you know, because of, I want to say moral consideration. It's not exactly morality, but somehow we kind of wired to have at least some preference for telling the truth, and we are just kind of utilizing these preferences. So it's not a situation that I actually can, hold the lie against you. It's exactly like, so I started with like this motivating example of a Fisher-Wacher uniformity experiment in which people roll a die in a cup, and the only one that see the result, and then they need to report it, right? And they not lie to the full extent. So this is kind of the situation I'm thinking about.
Yeah, yeah,
So
no, I totally understand that. And I was just thinking that still it might be something in the discussion that you might want to mention because verifiability is another source. I know you're focused on sort of intrinsic, like I don't want to lie about my preference for the color of the car, even though I could, because I think it's morally wrong. So if I really hate the color of the car, I should confess that to you. Um, and the uh, I agree with that, but it seems like there's sort of this spectrum of how difficult it is to lie, and at the one extreme, uh, informational problems are resolved by ex post verification.
yeah, you are definitely right. It's a good point to mention. Exactly discuss this kind of spectrum. Yeah, thank you. Still
Yes,
an
I also had
interesting
a question
topic.
about that. So one particular setting that would be interesting is um, simple bargaining between a buyer and a seller. Let's say the Myers and Satterthwaite setting. You might expect that if there is some cost of lying, people would happily reveal their values to one another, so that you would get more efficient trade opportunities. What have you thought about that, or?
Um, I think it's something that will be really interesting to think about. Yeah, it's also a nice setting to see what happens with the bargaining. We thought about it a bit. I guess part of it is that I think some of the results are kind of trivial. So if you do kind of like the one mole mechanism, then I think kind of like any bargaining result is okay because like the utility I lose, you gain, so everything is okay. So it's kind of getting more too trivial. But maybe there's another way to define it to get more interesting results. Yeah, thank you.
I have a question. Did you think about which settings or to which settings to apply it, this concept of morality? Because my guess would be if I participate in a contest, actually it's kind of expected from me to be competitive and to not care about others. At least this is kind of my intuition. So did you think about like which settings you want to apply it, or some measure of settings where some measure of where morality plays a higher role than in other settings? Because I would expect if I participate in a contest that it actually is detrimental, maybe, to the concept of contests if I participate less or exert less effort or yeah.
So first, it's not exactly like exerting more or less effort. I mean, I agree that like in the context of the contest, it will be slightly different. But so one type of applications could be these kind of smaller auctions in which people actually know each other, and in this case, there will be also maybe kind of like social norms that would make it harder to lie. And in such cases, it will be more applicable. And I guess something also central about this would be that people maybe are making decisions on behalf of themselves and not on behalf of some organization that they can, like hide, um, hide that it's not like making excuses. It's not their actual decisions, but something that they did for the, better of the organization. So it's fine to lie, but in kind of like a smaller situations in which, like a smaller group, people know each other. So I give this kind of example that I'm not sure if anyone is actually doing it, but maybe it's a good idea. That if you have a department in what you want to allocate, say, an expensive microscope, and one way of allocating it is asking each person how much he values it. And in such a setting, I believe that people are not going to be that competitive when they know, their friend next door actually needs it more. So this would be kind of setting that is applicable to these kind of things.
Another example would be wholesale electricity markets where they participate in auctions routinely. And in some markets, especially in the early days, there was almost a moral obligation to bid true costs implicit in the rules. The participants were encouraged to bid their true costs. And there are lots of disputes about that. And then, in fact, this is where the verification would become part of it, because in those instances where you have an obligation to bid your true costs, but you can, of course, lie, then in the event that somebody thinks that you're lying, the independent market monitor comes along and examines your costs and makes a cost determination. And then if you say, no, that determination's wrong, you can appeal it to the regulator, but essentially it's that process.
That's a great example. Yes, thank you.